We have a new module kit. Let us see the kit from online store. This is the diagram. NE555 plus 4017 Chinese. Di ko alam. I don't know the Chinese. Then we have the 555 timer, the 4017, capacitor, resistor, capacitor, and the resistors, and also the LED, 10 LEDs. This is the quantity. Chinese. I don't know Chinese. These are now our components. Let us see the components. I bought this from online store. This is the PCB. And as you can see here, this is an SMD type. Surface mounted device type PCB. Okay, let us see this. This is the SMD resistor. This is not a through hole technology. This is SMD resistor to be placed into the board. This one is the LED to be used here with a hole. Okay, and then we have this small IC type. This is 4017 decade counter to be placed here, and as you can see here, it's very small. Okay, and then also the 555 timer, very small SMD type, and the LEDs, the pin header, LEDs. Again, this one is the LED SMD type. You can see here, this is an LED SMD type. LED SMD type, and LED again, potentiometer 503 50 kilohertz, kilo ohms. There is another this is capacitor SMD type. SMD type capacitor, ceramics, and my fingernails are very dirty. Okay, project. We already finished soldering our project. Let us use the 9 volts as a supply so that we can test our project. Kill the light. Again the light. Kill the light. We can adjust the we can make it slower by adjusting the potentiometer. We can adjust the, so this one, okay, it's not slow, it becomes very fast. Okay, clockwise, counterclockwise is slow chasing, clockwise fast. Counter again, it becomes a slow chaser. So this is LED chaser. So this is the slowest setup. This one. Rotating the potentiometer counterclockwise. There we have the slow chasing of LED. While rotating clockwise, very fast. LED chasing. Sometimes it's called water flow LED running lights. This is the combination of SMD, surface mounted device, which is the soldering is critical, and also the through hole technology, THT. The pin header and the potentiometer is a through hole THT technology. We're using the hole, while the components, this is a SMD type, surface mounted device. We can also use 5 volts. Instead of using 9 volts, we can use the power bank. 5 volts. Using the cable or the power bank. USB to pin header. 5 volts. So there is we have not very much LED brightness, so we don't have we are reducing the brightness of the LED, but I think it's almost the same using the 5 volts and 9 volts. This is the schematic diagram of 4017 LED chaser SMD type. We have the 555 timer, 4017 IC, decade counter. And then our supply is, we're using 5 volts, also 9 volts. we tried the 5 volts and 9 volts supply. So we have this capacitor, decoupling capacitor, or this capacitor serve as filter noise to the line, to the supply, or stabilizer, 1 microfarad. And then what is the use of the 555 timer IC? It is used to generate PWM signal or pulse, on off, on off, on off, to the pin 3 output, which is going to the pin number 14, the input of the 4017, driving this 4017 IC. So in the 555, which is responsible for producing this PWM, we have pin number 8, the supply, 4 reset, 7 the discharge, 2 threshold, 2 trigger, 6 threshold, 1 ground, 5 control voltage, no connection. What is the use of resistor and the capacitor into the 555 circuit? Since we are producing an on-off or PWM signal, there is an on, and then off, then on, off, on, off. The component responsible for producing that pulse is the capacitor, also the resistor. So it charges the capacitor and then discharge. So while it's charging, it has an output. Discharging, there's no output. So there is an on-off signal or output into the output of the 555 timer. And you can control the chasing or the movement, the blinking of this 4017 by controlling the potentiometer, 50 kilo ohms. This is the potentiometer. The more resistance, it will slow down the chasing. So less resistance when the potentiometer rotates up to the pin number 3, which is low resistance. There is a low resistance. It will make the LED chaser to move faster or to. So this is the potentiometer responsible for the chasing. So since this 555 timer is responsible for making or producing this PWM, it injects this signal to the pin 14 of 4017, which is the input. 12 is the, if you're going to connect another 4017 IC, we are going to connect here 12, or cascading another IC, or if we need to have more LEDs, we can cascade another IC to the pin number 12. 13 inhibit, clock inhibit. 15 reset, to be grounded. Why? Because to work with the clock pulse, or we need to put it to the ground, or grounding the pin number 13. And 15 reset, in order not to reset the system, continuous chasing of the LED. Then here we have the output, 3, 2, 4, 7, 10, 1, 5, 6, 9, 11. You can see this is pin number 3, 2, 4. It means this is not just a decade counter. This is a sequencer. It has a sequence. So when we are going to first receive the first clock pulse, injecting the first clock pulse, it will turn on this LED, and the rest are off. They are all off. And then the second pulse, it will turn up now the first LED, and then this pin number 2 now will activate the second LED. This will now on. This is off. All the rest off. So it continues to toggle the circuit, toggling with sequence 3, 2, 4, 7, 10, 1, 5, 6, 9, 11. Ground is the pin number 8, and 16 is the supply voltage. So into the diode, we have the current limiting resistor. They are all using 1 kilo ohms in series with the LED. So injecting a positive pulse to the pin number 14 will cause the LED to toggle the light. When this is on, it will continues to toggle the lights. So you can see in the testing, the LED is just like chasing because there is a sequence number of pins involved. For example, if you're planning to press turning on the LED lights, pin number 3, 2, 4, 7, 10, 5, 6, 7, and 11. Okay?